In this video, we're going to continue example 371. We're going to look at parts B and C. In part 4, we looked at part A. We pumped the water out of the tank. In part B, we're going to pump half the water out of the tank. And in part C, we're going to pump this other half of the water out of the tank. So for part B, what I'm going to do here is just pretend that I have a 4-foot tank. We're pumping the top half of the water out, so we're just going to assume we have a tank that's 4 feet high instead of 8 feet high. So we're going to take the top half of the tank, chop it up into n equal pieces of size 4 feet divided by n. So the height of each little slice is 4 divided by n. What is the distance? Well, the distance is 4i divided by n. Taking the first little piece out requires one step of size 4 over n. Taking the second piece out, 1, 2, requires 2 steps of size 4 over n. Taking the third piece out, 1, 2, 3. 3 steps of size 4 divided by n. So to take the ith piece out, we lift this up 1, 2, 3, I times. So we take I steps of size 4 divided by n. That is why d sub I is 4i divided by n. Weight density of water was given to us as 62.5, and then we need the volume of each slice. The radius is 5, so the area of the base is still pi r squared, so 25 pi, times the height. This gives us the volume of these little cylinders here. So we have 25 pi times 4 divided by n times the weight density of water. This is the force of each slice. Force times distance is work. So we have our force times our distance. That is the work required to lift each little slice out. So we take the sum, I equal 1 to n. That is the work required to lift all n slices out. But this is only an estimate of the work. We want the actual work. So we take the limit as a number of pieces goes to infinity. And so we do something similar to what I did in the first video. We recognize this now as an integral. So we're going to factor the 1562.5 pi out. And when we look at the limit as n goes to infinity of the sum I equal 1 to n of 4 divided by n multiplied by 4i divided by n, for the same reason as in the first video, we had the integral from 0 to 8 of x dx. We have the integral from 0 to 4 of x dx. And so find an antiderivative and evaluate that. It's in the notes. I won't do it here because I want to save board space. But we have 12,500 pi foot-pounds. Maybe not the answer you were expecting. The question is, why isn't it just half? Before we had 50,000 pi foot-pounds. Now we have an answer less than half of that. Here's the reason. It requires less work to pump the top half of the water out than it does the bottom half of the water, because the top half doesn't have to come out as far. And so our distance is less for the top half of the tank as it is for the bottom half of the tank. That's why our answer is less than 1/2. We might have just guessed initially that the answer would be 1/2, but it's not. So that's why it's less than 1/2. Okay, for part C, there are 3 different ways to do this. This is a little bit different than what we did in the notes. So if you look at the answer in the notes, what I did is I looked at this part here and said all of the water has to be lifted up to here plus another 4 feet is how I set that up. So this slice, now we're emptying the bottom half of the tank. So I said, okay, we'll take 1 step to get to here plus 4 more feet. Then we'll take 2 steps to get to here plus 4 more feet. We'll take I steps here to get to this point and then plus 4 more feet. And so we set the integral up from 0 to 4 of something. Okay? There are 2 other ways to do this. The way I've done this here is, okay, we have set this up twice, and we see that we're integrating x dx. this constant times x dx. The question is, what are we integrating? Well, to empty the entire tank, we integrated 0 to 8. To empty the top half of the tank, we integrated 0 to 4. So think of the top as the 0, the bottom as the 8, and we integrated from 0 to 4 to empty the top half of the tank. How do we empty the bottom half? Now we integrate from 4 to 8. So integrating from 0 to 8 emptied the whole tank. Integrating from 0 to 4 is the top half, but now integrating from 4 to 8 is the bottom half. That's how I've set this up. So we integrate from 4 to 8 of this function, and that gives us 37,500 pi foot-pounds. That is the second way to do this problem. What's the third? Well, in part A, we calculated the work required to empty the tank, which was 50,000 pi foot-pounds. In part B, we calculated the work required to empty the top half of the tank, which is 12,500 pi foot-pounds. So what is the work required to empty the bottom half of the tank? It's the difference. It's 50,000 pi minus 12,500 pi. So you take the answer from part A, subtract the answer from part B, and that is the answer for part C.